This is the Epsilon XL3, a 4-meter wingspan glider, or 157 inches. I bought this glider many months ago, and finally I could finish it. Although it is an ARF, it took me so long because I was waiting for the right brushless motor to be in stock, also the ESC, and the right servos. But finally I finished it. And what you are about to see is its first flight. These images are from the next day. The weather was even better, so my idea was to hunt some thermals. Here you can see the onboard camera on the glider and the sticky inputs in the radio in real time. You'll also be able to hear the beeping of the barometer when I activate it.
Telemetry lost. Telemetry recovered. Telemetry lost. Telemetry recovered. $113 meters. $174 meters.
As I said, the weather was good, but I didn't find any thermals. If you want to see the complete video of the entire flight, I'll leave the link in the description below. Landing.
Telemetry recovered. Landing mode on. Telemetry lost. Telemetry recovered.
Okay, so let's take a quick look of all the electronics that I have in the glider. It's very interesting because this one have a lot of things that I haven't used before. Like, for example, let's start with the receiver, which is a GRX8 from FR Sky. It has a variometer built in, so we can measure the vertical speed and altitude. So that's why you can hear in the radio when I'm going up or down, just like in a real glider. I don't need an external sensor for that because this receiver comes with it. And then we have here, I also put this sensor that it's for measuring the voltage of my LiPo batteries on board. Well, the main LiPo battery, you can only connect one. So the valence port goes connected to these pins here, and it will tell you all the voltages of each individual cell or the overall voltage, and you can set up a alarm in your radio when the voltage drops below certain threshold. So this is very useful to know your battery levels. And then I have also a redundancy receiver system, because this receiver has the S-Bus in port, so you can connect another receiver that has an S-Bus out port, and I have the other receiver on the tail, and the antennas are displayed in 90 degrees from each other. And this receiver, it's also here, has the antennas. I don't know if you can see that, but I have one antenna here. So it's 45 degrees with the mean line of the fuselage, and the other antenna is also here. So all the antennas go outside the fuselage because this fuselage has some carbon fiber in it. So yeah, they are 90 degrees between each other, and that's good, but I decided to put the second receiver for better quality signal. And what else? I have also the redundancy power system, which is a very simple system. I have a second battery here that goes connected here. So it could be just a small one, could be a 2S or 3S battery, goes connected here. Then this is a buck converter, and it converts the voltage to 5 volts, and it goes connected to one of these guys. So that one is inside over there, but you won't be able to see it. It's also wrapped in electrical tape. And this is a very simple thing that I have made a video just a few weeks ago. And this goes connected, this has two inputs, so you can connect your ESC and a secondary power source like this. So the ESC goes connected in this pin that is marked with the S, or these little arrows here, or triangles. So this is the ESC. And the ESC, of course, has a regulator, or a BEC, that outputs 5 volts, so you can use your 5 volts in the output. But also you can connect the second power source, which is also 5 volts. But you can use whatever voltage you want. It doesn't matter because the diodes are going to prevent that voltage from charging the other battery, but it will actually go out. So if your receiver supports 10 volts, you can plug your 10 volts battery or whatever and power your system, but you have to be careful because your servos have to be also 10 volts. So yeah, this is a system. It's very simple, only using diodes. So if one ESC goes out, or the ESC goes out, burns or whatever, or the battery just burns, then the second power supply or the second battery will keep supplying voltage for the system to power the servos, so I can land and save the airplane. So this is basically the main things that I have in my airplane. The key features are the redundancy receivers and the redundancy power. So I have a reassurance that everything is going to work, even if something goes wrong. So yeah, so that's basically it. And I still have to work on the calibration or the trimming of the airplane and many other things, but those are minor details. The good thing is that this is already flying. And it's 4 meters of wingspan, which is very impressive. I really like this glider. Now I have to go to the mountains and test it there. The batteries that I'm using are 4S, but I reckon I should use a stronger one, like a 5 or 6S, to have more power when I'm flying in a flat place where there's no mountains. So this is the one that I use the most. It has the perfect weight, so the center of gravity is in the right position. And this one is 4000 milliamps, as you can see, and it's 4S. But I can also use these 5000 milliamp hour batteries, 4S as well, but they're heavier and the center of gravity goes a bit forward, but still it's flyable. And yeah, they're okay. But I'm gonna think about taking a 6S and see how it goes. But for now, I hope you liked this video, and thank you for your support. So I'll see you soon in the next project.